So you work for a company that produces smartphones, and you are advertising that the newest product can survive drops from great heights. Your company wants to find out exactly how far the phone can fall without breaking, so they give you two phones to perform test drops from an 100-floor building with 99 stories higher than ground level. What is the guaranteed minimum number of drops it will take to determine the safe drop height? To get a feel for this problem, you should know that you could just walk up to the 99th floor right away. If the phone does not break, you are done, but if it does break, you have no new information. Maybe it can only survive 50 stories, maybe it can survive 90 stories. Your first drop told you nothing. You could also start at the first story above ground level. If it breaks, you know that you'll probably have to keep working on your product. If it doesn't, you can move up to the second floor and keep moving and dropping it until it breaks. The problem is, what if it can survive 50 stories or 99 stories? If we assume every story has 10 stairs, you would first have to walk up 10 stairs, then down 10 stairs to retrieve the phone, then up 20 stairs and down 20 stairs, then up and down 30 stairs. If it survives 50 stories, you'll have to walk up and down 12,750 stairs or 25,500 total. If it survives 99 stories, you'll have to walk up and down 49,500 stairs or 99,000 total. So we have to find a way to split up our test in a way that will be more efficient. A good place to start is that we could split up the 99 stories in intervals of 10. So let's say we start by dropping the phone from the 10th story. If it breaks, we know the phone's limit is somewhere between 1 and 9. We can then just drop the second phone from the first floor and the second floor and so on until it breaks. If it survives up until the 9th floor, we found the limit in a maximum of 10 drops. Now let's say it doesn't break on the 10th floor. Then we can go up to the 20th floor and drop it. If it breaks, we know its limit is somewhere between the 11th floor and the 19th floor. We start at the 11th, then the 12th, and so on until it breaks. If it survives up until the 19th floor, then including the drop on the 10th and 20th floor, it took us a maximum of 11 drops to find the limit. The problem is, the longer it survives this method, the more drops it will take. If its limit is the 9th floor, then we will need a maximum of 10 drops. However, if it survives until the 99th floor, it will take 18 drops. There is another method that will ensure a smaller number of drops than most of the scenarios involved with the increments of 10 strategy. We have to split the floors up so that no matter how long the phone survives, the maximum number of drops needed never changes. You should notice that the maximum number of drops increased by 1 every time it survived a drop for one of our last increments. To fix this problem, we can decrease the space between our increments by 1. Start by dropping the phone from the 14th story. If it breaks, you can drop the second phone at stories 1 through 13 until it breaks. At most, it will take 14 drops. If it doesn't break, decrease the increment by 1. So instead of going up 14 more floors to 28 above ground level, go up 13 floors to 27 above ground level. If the phone breaks at 27, then you will have performed 2 drops so far at floors 14 and 27, and you will need at most 12 more when you start dropping the second phone from floors 15 through 26, for a total of 14 drops. You can continue with this method, dropping the phone from floors 39, 50, 60, 69, 77, 84, 90, 95, and 99 until it breaks. No matter when that break happens, the most number of drops you will need is 14. Other strategies have possibilities that could end up with less than 14 drops, but they also have a lot of possibilities that could end up with more than 14 drops. This strategy ensures that you will need at most 14 drops no matter how durable the phone is. Thanks for watching, and here are some extension questions.